Hi again. So let's take the concept of hypothesis testing a little further. So suppose the null hypothesis states that the hypothesized mean is equal to the actual mean, and the alternative hypothesis states that the hypothesized mean is not equal to the actual mean, right? So this is the curve of our sampling distribution, all right? And this here would be our hypothesized mean. Now, if we collect a sample and the mean happens to fall in the rejection region, which is, this is the non-rejection region, non-rejection region, and these would be the critical values, on either side. These are the critical values. These would depend on whether we are using the Z distribution or the T distributions, the student's T distribution. So if our mean happens to fall outside the non-rejection region, then we would reject the null hypothesis. And so when we have type 1 or type 2 error, what happens? So this, as you all know, is a sampling distribution. Alright, so what happens is when sometimes we collect a sample and it falls on either of these tails at the end of the distribution, okay, at either of the tails of the distribution, then there is a possibility of having a type 1 or a type 2 error. What I mean is that if you had collected, suppose, 10 more samples, you would have understood that all the means of those samples probably lied within the non-rejection region. But you, just by chance, you happened to collect a sample where the mean, suppose the mean lies here, or the mean lies here, just by chance, alright? It is possible that the mean does lie outside the sampling distribution, but just by chance, if you would have collected probably 10 more samples, you would have learned that the means, actually all the means lie within the non-rejection region, but you happen to collect a sample by chance which lies outside the non-rejection region. In that case, you would be committing a type 1 or type 2 error, as the case may be.